All right, so welcome everybody at this pond session. We are making a snake game. And if anybody would like to share their snake game, give me a sign and maybe you can share your screen as well. Johan? You want to share?
I can share my screen, sure.
All right.
And
I'll stop presenting.
this is my
Hey,
snake game.
Gabrielle. Hey. Okay. Wow.
Yeah,
What a marvelous snake game.
right?
All right. Great. Gabriela, we are making snake games. So
Okay,
this is
nice.
basically Hey Jonathan.
I hear myself through you.
Hi.
Yeah, I think maybe we should join our audios again or something. I think that would be nice. Jonathan, we are making a snake game. Does anybody else have a snake game already? Yeah, Paul, you wanna share? You wanna share?
I can. It looks very similar to the one that was just.
Oh, wow, it does look very similar. Okay. What did you use? Did you use Claude?
Yeah,
Paul?
I used Claude Code. Yeah.
Claude Code, yeah, okay. All right. All right, so I'm gonna share my screen again, and let's get into the presentation. So that's really funny that your snake games look so similar. I mean, it really, of course, depends what kind of prompt you give the model. And I tried this with multiple models with different prompts, and like the first one of the GPT plane, it kind of really looks like let me just full screen this. It really looks like the Claude one that you did. I tried also with DeepSeek, so just make me a snake game. As you can see, what DeepSeek did is that it gave the snake eyes, it gave the snake a tongue, it made the balls little apples. Then I prompted different Claude models. So on the left there is Sonnet. I made it make me a snake desert game, and Claude Opus to make me a space snake. As you can see, that it starts to get a bit different, right? So here in the Sonnet, I get for some reason here, and in both of them, I get like obstacles, right? In that I cannot like bump into. In this Opus one, I get a plasma orb and a star fragment as something that I can collect, which is also like super random. I didn't ask it to give me two sorts of things. I asked Haiku to make me a tea party snake, and it came out as like a little teapot with cookies chasing coffee cups. So this is a session on how to code anything, including snake games. This is a rerun from Dataharvest 2016. You know me, I'm Ada, and with me there is Johan, who will also say some smart things later. I would also like to ask you if you can and if you feel comfortable with it to show me your face and to to basically allow your webcam so I can kind of see. Hey Esther, so I can kind of see also facial reactions and I can feel the room a little bit. That would be super nice. All right. So what have we coded with LLMs? So very briefly, well, this presentation I made with LLM. It's a presentation made in Reveal.js, which is a JavaScript framework for presentations. My website is Datafrosh. I also make with a large language model. It's a simple HTML website. There's nothing fancy going about. This website was still designed by Claude like last year. It was still in the time when Claude was designing like random quirky things and not like everything now looks Claude. Like if you now design a website with Claude, you can really see that it's a Claude website. I made this from a data set. This was a tabular data set that had the information on media owners in it, and I kind of wanted to see this as a network, so I can click around and I can see how media owners are connected within this large network. On the left side, I have vibe coded some filters for myself so I can look, and I have basically done all the interactivity in the network also with just vibes. This dashboard on for a project that I'm going to hopefully do with Gabriele is about a farm subsidy that goes into the Alpine regions, where I took data sets from Austria and Italy, and I used Claude to filter down the data sets to only the Alpine regions based on postcodes and municipalities. And then I used, after I filtered the data set, I made this dashboard for this data set. So I can share that with Gabriele and with our colleague Christine, so they can also have a look at the data. So they don't need to, code, or they don't need to use databases or anything like that. So it's a simple way to share data with colleagues. And I also use it for my essays. So I made this essay beginning of this year where I used Claude helped me to build this interactive, like basically the whole web page, including the interactive data visualization. So you can use large language models these days for really everything, in terms where you needed to know how to code before. You don't really need it that much, and you need it a little bit more with some things, a little bit less with other things, but it's way more approachable now. And this is what Johan does with LLMs, and this is a little bit more complex, and maybe he wants to talk about it briefly.
Oh, sure. I built the whole every politician project inclusive of all the data tooling around it fully with LLMs, like Paul, don't tell Friedrich. It's a tool that takes Wikidata and the internet and smashes it together, and out rolls a list of all the politicians on the world. That's the cell. So this is an example of the tool. It takes Wikipedia page here on the right. It extracts structured data that you see on the left, and it keeps references to the original data in the source. So we're doing this now also in some sort of automated way where we scan the internet. But this is all vibe-coded software. And I would love to get rid of the vibe code label. So I would love to call it just software engineering with help of language models. Because there's many tricks that you can follow to keep your results consistent and testable. And that's all I have to say now.
We'll come back to that. All right. Oops, where am I? Oh yeah. So what actually happens when we prompt the model for a snake game? All right. So the model knows what a snake game is because it has this concept in its training data, right? As you know, these models are trained on all this data that has been stolen from everywhere. And in this training data, there is a concept of a snake game. Now, this hold this thought, because this training data part is going to be super important throughout the whole presentation. So it also knows, because of this training data, how to make artifacts. I mean, it knows how to make interactive artifacts. It knows how to use JavaScript to make this snake game, and it has the ability to do interactive artifacts because of the nature of Claude or ChatGPT or whatever. However, as you saw in my snakes, not really much Paul's and Johan's snakes, it will make, also you actually saw that in Paul's and Johan's snakes, it will make arbitrary choices, you know? So how does it look? You know, like your Paul and Johan, your snakes were green and the background was black, and you didn't probably tell it for it to look like that. This was a choice that the model did itself. How does it behave, right? Like, does the game end when you hit a ledge, you know, or does the snake go through? This is a choice that it made itself if you didn't tell it. So the walls end the game. Under obstacles, as we saw, you know, like there was in some cases there were obstacles, some cases there was not, some cases the snake had eyes and a tongue, in some cases it did not. So we don't want this, okay? This is what we are going to talk about today is how to minimize a behavior that is arbitrary by these models. So today what we're going to cover are 4 main things, which is prompt, the context, it's local agent, and it's the plan, implement, review loop. All right. And if you have questions at any point, please unmute yourself and ask, right? There is no like beginner's question. There is no like, I mean, there are beginner's questions. There is no like stupid questions. And maybe your question will also enlighten things for other people. So please I encourage you to ask questions. All right, prompt, right? Who has heard about prompt engineering? Like prompting, yeah, like prompting was really the shit, right? Like last year everybody was talking about prompting. So like your prompt shouldn't be too specific or too vague, it should be just right, you know, and there are all these structures for a good prompt, and like you need to give it a task and a role and guidelines and tell it what output format you have. This still applies. However, as we work more and more with this technology, we learned that it's better that the robot prompts itself. Okay, so we are actually not the ones who make the most of the prompts, right? We cannot be comprehensive enough, basically. So what I would actually like to pay attention to more is the context. Okay, so context means providing background, and it's crucial for effective communication. Okay, so I'm going to jump to context immediately, because context management is actually something you should be looking into if you're going to work with large language models. So context means that we're making sure that the model gets enough information to perform its task well. Okay, this is also like I've seen some of my colleagues like showing me that the model is stupid by just giving it a little prompt, asking it to do something, and then it would do something like stupid. And then they would be like, look, it's doing stupid things. And I'm like, yes, because you cannot use it. So what is context, right? So we as context, we think documentation, methodology. So if you want to write in a piece of with a particular software or libraries, you can feed it documentation. If you work with data, you can feed it the methodology of the data. If you are doing research, you can feed it reports that were already done. Examples, always a very good thing to put into context. And tools. And we're going to come back to what tools are. And Johan wants to say something.
Yeah, I want to say that the way to know what to feed it is basically quite simple. It's just what you would need yourself to answer the question you ask the model. And there's also the models nowadays have so many tools to gather this sort of context themselves also. So what I do often is that I literally tell the model, hey, based on the documentation that you can find, what can I do? You know, stuff like that. You can really have the model gather its own context.
So where prompt is like very bare bones, you know, you just have the system prompt and the user message. If you work with context, you can give it all these different things and a prompt, and then get the information back. So it's not necessarily more complex. It's just a little bit longer process. Because if you don't give it context, it will rely only on its training data. You remember when I was talking about training data, how it knows what snake game is because of its training data? So training data contains information, but it also is the reason why the model hallucinates. Okay, so if the model is only relying on training data, you get more randomness. So this is a screenshot from the facts benchmark. And what this shows is basically this average score is when you ask this model a factual question. Factual, right? So what year, who, how, you know, just facts. In what percentage of the cases it will tell you the truth. And as you can see, GPT leads here with 70%. It's still not like enough. Claude, it's 50%. This means that in half of the cases, Claude hallucinates facts. Right? So, however, if you have the model use a tool that is called web search, the percentage goes up rapidly. You see, then the facts are 85% good. So it's and this web search thing, this is just context, right? You give it information around your question that allows it to give you a proper answer. So you can, the way to think about these models is also instead of thinking of them like helpful assistants, which is like everybody wants to think about this, like this is your helpful assistant. No, it's a transformer basically. So what it does, it takes input and it transforms it to a different output. It's not a human. It doesn't think. It doesn't reflect. It doesn't know what is interesting. It doesn't know what is newsworthy. It transforms information, right? So, and the more information you give it to transform, the more accurately it can transform it into whatever you need it to transform. And why does it work this way, Johan?
Another way to look at these models, if you take the sort of machine learning approach to this, without getting into that whole community, but in that community, the conversations you have with these models, they are called trajectories. And that is with a reason, because when we have this model and we prompt it, what we're basically doing is that we're requesting the next token, the next word, so to say, you know, and we do that a lot of times in succession. So when we have no prompt and we just have this statistical model, we have all these possibilities to end up with as output. You know, the whole world is open to us. But the more tokens we put into context, the more tokens we feed, you know, and the more detailed our prompt is, the smaller this little space of possible outcomes becomes. So we see this as a trajectory, because we have this huge multidimensional space of possibilities, and we are reducing this space with every token more that we put into this context. So that's a way to think about that, and why this hallucinating happens a lot when we rely on the models training data, and why doesn't it happen when we have the information in context? Well, these models, they have lots of parameters, you know, like they're big sort of like bags of, well, in this case, floating point numbers. It's like, let's say there's a terabyte of model there, but they have reduced and compressed all the training data, the whole internet. Like, it's unimaginable how much that is. They have compressed all that knowledge into this small 1 terabyte space. So the model doesn't know everything. The model only has a statistical possibility or probability of what the answer can be, what the next token can be. So when we feed this context, the models are very good at repeating what is already in the context. So this is where this attention mechanism that you might have heard of comes into play. So this is why information that is in context is very easy to get to for these models, and information that is in the weights, that is compressed into those weights, is compressed information and therefore very unreliable. So that's my 2 cents on this.
Yeah, I'm also wondering, because like some of the context you might not know before yourself. So could you just ask the model to find the right context for you?
Yeah, absolutely. Depending on the tools that you use, most of these web chats nowadays have a couple of these web search tools in there. Basically, we'll get to it later, but an agent, nowadays everything is an agent, and an agent is just this model plus a couple tools. And depending on the tools these models have, they can get context from your local file system, or they can get context from the internet. And you can also extend this functionality with tools to get context from maybe your search index or something else. So this agentic behavior really allows the model to fill that context itself. So if you have ever used this local coding agent, when it starts reading files, etc., that is the model filling up its context with relevant information to answer your specific question or request.
Yeah. And I was then wondering, so like a web search can be very broad, right? And I think if you search the web yourself, you have this, or you evaluate whether it's relevant or if it's a good source. Can you steer that as well within the model? And the tool, then the web search tool, or is that really difficult?
The model will steer itself. So if the model can determine whether the information is to answer your question is in there or not. So to give an example, what we do with the Polyloom tool to match these like positions of politicians to stuff that is already in Wikidata, I have it search in English, for example, and I tell it like, hey, if you don't find it, how about you also search in the local language and stuff? And that is part of my prompt, you know? So you can kind of like direct the model, telling it what to do in case it cannot find the information, or you can kind of like give it a strategy. Yeah.
What I do when I research, I do it in parallel. So I do research myself, like I do the search myself, but I also give the agent the prompt to search. And what is good practice anyway is to then have it if you have it give you output, tell it source me everything with like the links, so you know where it took the information from, because it is true that sometimes it will steer itself into websites that when you look at them you're like, okay, but this is like, for example, this is a lobby website, right? And that's something that you can assess yourself. However, what you can also do is instruct the model to say, don't get information from websites that are of lobby groups, because the model also knows, and this is because of the training data again, what is a lobby group, and it has actually the names. So if you just ask it to I would encourage you to also play with this later. Like if you just ask it to like give me a list of lobby organizations in agriculture in Europe, you know, that lobby the European Union, it will probably give you a quite nice list. It probably won't be comprehensive, but it knows quite a lot already.
Yeah. Okay, thank you.
So these are 2 practices for context building that I practice myself. Again, this is not an exact science exactly, but so what I first do is that I discuss. So let's say I have a problem, right? I want to write a scraper, and I have this website. So what I tell in my case Claude, I tell it, okay, I have this website, I want to get this and that information out of it. Look at that website. Tell me how to get this information out of it, you know. And if it's a bit more complex issue, I also tell if I don't know what I'm looking for, it was also your question, Esther. Like if I want to make something more complex and I don't know if I'm not missing anything, I ask the model to ask me questions, and it sometimes does that automatically. But I sometimes also tell it explicitly to ask me questions. So what I see, namely with journalists often, is that they really keep their prompts really short and everything, but actually the longer you you should really talk to the model and discuss your problem until you have like a good picture of what you want to do when we talk about coding. So coming back to the snake game, right? This will be something that I could say to the model. I could say, I want to build a simple snake game. What are the steps I need to think about, from the core mechanics to the visual design, right? Then I don't have to think about everything myself. And this is an answer that I got actually from a trace with Claude. It will tell me, like, these are the 6 things that you should think about when designing a snake game. Super helpful. You know, what are the core mechanics, how the snake moves, the game world, the food and growth, what is the collisions mechanics, the scoring points, visual design. So this is a very simple example, but this is obviously useful for anything you're building. Sometimes each of these steps might need different context, however, right? So if you're building something more complex, the core mechanics, might need its own context. The game might need its own context. The visual design might need its own context. So that's why we need to divide the work well, and especially if we work smaller models. So currently, everybody, GPT 5.5, I think it is, and the Opus, and these are very big models. But I think what I see Johan doing as a software developer, but what I recently was also reading about on The Economist, so it's coming to the mainstream, is that we are going to move towards smaller models probably because they are cheaper to run. And what is a smaller model? That's this example was taken at the workshop because people were working with open code, and open code comes with a free model, which is the DeepSeek V4 Flash. But you also have DeepSeek V4 Pro, and these models they have a different size. So we are talking about the parameters here. As you can see, DeepSeek V4 Pro has 49 billion parameters. DeepSeek Flash is 1.6 trillion. Okay, maybe you want to talk about it.
A couple things with these models and these parameters. What this is like floating point numbers. It's the weights of the model. So you have a certain network structure that is very similar, shared between these models. It's all transformers, and what gives the model its magic is these learned weights. And this is the amount of weights that these models have. So you have, for the Pro version, you have 1.6 trillion parameters. That is kind of like Opus sized, you should think. And the Flash model has these 284 billion parameters, which is kind of like between Haiku and Sonnet. And this is all like, we don't know how big Opus is, but this is the guesses. And then there is like the context window. This is how many tokens can you smack into the context of this model and still get answers. These numbers are fake. 1 million tokens is yes, you can smack it into the token into the model, but the model will roughly stay smart up until like 100,000 tokens, and from there on out they kind of hack in more context, which is kind of like a hack, really. Like keep your trajectory short, because this you end up getting a model that keeps getting dumber and dumber the longer you go. Then there's precision and all this other stuff, but I don't think we have to really get into that now.
Yeah. So what Johan touched upon about, this model stays smarter until around 100,000 tokens. I can maybe quickly show you. If I go here and let me see, Claude. So where's my code? If I go to Claude and I say context, right? It will show me this image, which is the context usage. And Claude Opus also has like 1 million tokens, and currently there is no context usage. There is just the system prompt and the system tools. There is some skills and some messages. There are not that many messages. There are 8 tokens. So this is basically the context. And once I start to talk to Claude and be like, let's build a scraper, which is a very bad prompt, but just for the sake of demonstration, now it will start to build its own context, right? So it will here it will start to read what's in this particular folder, and it will come up with its own results. Here you got a full picture, wonderful. Then it starts flambeing, and as it now it asks me questions, like whatever. But as you can see now, if I press context, it starts filling up. You see, like before there was just like one message with 8 tokens, and now suddenly I have 16,000 tokens. However, the more tokens you put in here, the more there is a chance that you start confusing the model, or that the model starts to get a bit confused. So, like we were talking about, the smaller the model, it's more important to divide the work well, but also with larger models, like if you can keep your work divided into where its core mechanics is one context, the game world, it's another piece of context, the better. So the shorter you keep your context building and the more focused, the better. We get into how to do it practically in a bit. So these are roughly the takeaways. So you build the context through conversation with the model and external sources. And you should split the big tasks and provide only the relevant context for the task, for the small part of task that you have. Questions about context? If there's something that's not clear, doesn't make sense? Okay. So enter the local agents. So why do we use local agents? So I had this I had Claude write me a scraper. Johan?
I'm curious, how many people here have used like a local agent before, like OpenCode or Claude Code or Codex? Raise your hand if you did. Okay, thank you.
Veronica, yeah, okay. Esther, nice. Yeah, so for people who didn't, the reason we would use local agents is because if I, for example, have Claude write me a scraper in the web interface, it cannot run it because it's sandboxed and it has network disabled. So you cannot run scripts from the web interface. That's one reason. Another reason is that you can upload your files there, but it's kind of awkward, right? You can upload your files and then get files out, and but you need to do like this constant the constant moving between the web interface and your own computer. So this was kind of the hands-on that we had in the session where we had people ask what an agent is. So I can do that now. So I can say So now that I'm going to start something new with Claude, I'm gonna do /clear. What this does, it clears the context until now, and it allows me to just start with a clean slate. See, this is gone again. So I will do this every time I want to start a new iteration or a new conversation. I'll just clean the old context so the model is not confused. So I'll ask it, what is an agent? And you can absolutely do this also at home. This is to show that you can, the beauty of this tool is that you can ask this tool about itself, and it can tell you about itself. Okay, so this is a tool. So iCloud Code, I'm an agent. If you give me a task, I can read files, run shell commands, edit code, and call tools. So I can say, what tools do you have? Right? And then we will tell me. It has the read tool, so it can read any file. It can edit, write files. It can execute bash, which is command line commands. It has ask user questions, and it has a couple of skills that I gave it. So I have this skill, for example, to reverse engineer hidden APIs. Yeah, it has web fetch, web search, Chrome DevTools, which allows the robots to pretend it's a human through the browser. Also very handy because of everybody's trying to block agents now from accessing stuff. And it can do many things. So you can basically also give it any tools that you want. Okay, so so what is an agent is basically a model with the ability to execute tools. Yeah, that's what makes it agentic, because it can act. It can do something. And the local agent, in addition to everything, can also read and write files on your computer. That's basically it. So an agent is a model and tools that can act on your own computer. Oh, a local agent. Beware that local agents can access your files and execute code on your computer. So, for example, when I every time I run Claude on my computer, I make a new folder for it, so it can act only within that folder. Okay. I saw on the workshop that we gave that people will just run the project in their home folder, but when you do that, then the agent has access to all your files, which you don't want, because A, it's polluting your context. Not all your files are really important for what you're going to ask. B, it's also something you just don't want, right? It's privacy breaching, and probably other things breaching. So make sure that you always execute your agents that you always run your agents in a separate folder. And the collection of tools is called the harness. So this is also a term that you might encounter more in the future. So for example, Claude Code is a agent harness. Codex is also an agent harness. Open Code, which is software that we used in the workshop, it's also an agent harness. So it's basically it's a collection of tools. Yeah, it's basically a piece of software that allows the LLM to become agentic. Okay. Any questions on agents, local agents? Okay, great. And the last part, yeah, Jonathan?
When you have local agents, you have to download a whole load of stuff to your hard drive, don't you? And then are you going to spend a lot of time maintaining it, so you're always up to date, or do you just have a corpus that you take the first time and keep using it?
What do you mean with that? What would you
Well,
download?
when you got a local agent, what are you actually putting on your hard drive? A whole model?
No, you're confusing an agent with a model here. So what we're talking about, if we're talking about a local agent, is a agent harness, a piece of software like Claude Code or Codex that has tools that access your computer. So Claude Code can execute read file and read a file from your computer.
Mhm.
That's why we call it a local agent. And if you're talking about
Okay.
local models, yeah, then you pull
okay, I
in
was
like the
confused.
big model. Yeah.
Yeah, sorry.
Yeah, no worries. That's okay. Esther?
Yeah, I wanted to ask you about something different. So I've been like, I know that you can just use it in the terminal and then use Cloud, and that's what you do. But then you also have the desktop app, and I just recently started using the desktop app because I just find it easy to switch between chat and code. But then I also now just realized that, of course, then I'm not really setting a separate folder. So can you explain to me a little bit, like, is it really just smarter to use a terminal, or is like the app fine as well? Can you explain something maybe about the difference?
I think that I never used the app, to be honest, but I think the app really forces you to open some sort of project folder, no?
Well, it actually doesn't. So it's like in my main one, but you can set it to a project folder. But like I would indeed in the terminal, I would always navigate to a folder and then start Claude.
Yeah.
But I just realized now that I'm definitely not doing that here. But I've also not been using it loads. So like, but yeah, like it's now just set to my main folder. I realize. But yeah, anyway, if you haven't really tried and compared both, then I can just Google it. What's the downsides?
Under the hood is the exact same piece of software, so it's up to you really to put it into a folder. And that's depending on how much you trust these huge American companies. That is something.
I know, yeah. I just don't. I guess so.
Yeah. Paul, yeah, you have a question?
Yeah, it's actually a follow-up of the same question because I have used both. And there is some differences I find in functionality in the terminal version. Like there's a few things that you can do, Esther, that I as far as I know, you can't do with the Claude Code like desktop interface. One of the ones that's kind of useful is sometimes the agent is taking its time to do stuff, but you have like a readout, and this is true. You have this on the desktop version where it says what it's doing, like what it's thinking, what it's working with. But in the terminal version, and I'm pretty sure you can't do this with the desktop version, you can kind of ask questions about what it's doing as it's doing it, and it queues them up in the background and doesn't stop the whole process.
Okay.
To like answer them, and that can be really, really helpful, especially when you're getting a sense that it's kind of like going off piste in what it's doing. And that you need to inform it. But I was just also wanting to like ask other people if they noticed any differences, like in actual features between the terminal version of Claude Code and the desktop.
Yeah, I really can't say. I really can't say. But I mean, try terminal, guys. It's
No, I guess but maybe this is the way, like I've done, like when I really start a bigger project, I think I would automatically go to terminal. But then I think lately I've just asked it small things, and then now I just have the desktop app open and I switch between the chats.
Yeah, the
chat. Then would you in the terminal ever go to the chat? Can you go to the chat in terminal? You just
it's a chat as well, you know. It's like I don't really go. Like I use the browser window chat sometimes, just for quick questions. So I use it in browser, and I use Claude Code for work when it really needs to do some work. Yeah, but like for example, when I do context building for anything, I also do it in the terminal. So what I then do is that I will have a conversation with it, do some research, and then at the end of the research, it will output me a file of some sort that I can work with, or anything like that, or it will output a prompt for me that I can use for a next iteration. So I do most of my work in the terminal still.
Thank you.
Because my mic doesn't pick myself up. Yeah. Like you can see these two things, this chat and this code, you can just see it as two harnesses, right? Like the chat functionality only has like a web search and only has like a web fetch, you know, can fetch a web page and stuff like that. And the coding version is just a bit more, couple more tools, but it's under the hood. It's the same model you're talking with, and it's the same thing basically. And it also has
but
a
what
website.
I had before is that like I asked it some general question and I was still in the code tab in the app, and then it interpreted it as that it had to make some app. So like
Yeah.
I was like, no, this is not what I
Yeah.
want. And I was like, oh no, it's clear. Like I just need to ask it in chat. I don't remember what
Yeah.
it was, but like it does expect something different. So like that's why I
Yeah,
wanted.
the system prompt there is very different. So the system prompt for function will be very much aimed at like, hey, we are coding harness and we make
Yeah.
code.
And I think like also like they have this Claude design now, and you can use Claude design to design a web page. And I tried it, and everything just looks like the same. And then if you use Claude Code, which is way broader, I feel if you use it to make design, the design also looks very different. So the system prompt really makes a difference. And I have the feeling that Claude anyway, Anthropic anyway, like puts all sorts of random things into these tools, and I feel that they do that maybe still less with the code. Yeah. All right, guys. Let's because we have like 10 minutes left, so let's get to this last part, which is this plan, review, implement loop, which is basically how you would make a piece of software, right? So as you maybe know and maybe not, and I will clear my context. Here, as you can see here, I have this auto mode on, which means that it just automatically can do whatever. But I can switch here into plan mode. And plan mode, so what I do when I start working on something, I start working on it in the plan mode. In the plan mode, it can still call tools, it can still do web searches, but it still can read files, but it cannot write files. It cannot write code, it cannot edit code, it cannot basically edit anything on the computer. So that's the plan part. Then from this plan mode, so let's say in here we had make a scraper for books to scrape. Okay, so I'm just going to show you a very, very simple workflow. So if I would start in plan mode, and this is a very simple scraper. So this will be just one iteration. Please write me a scraper, and you don't have to say please, obviously. For books to scrape.com. Go to the website, find out what is there to scrape. Like, obviously, I should go there myself, right? And just look what's there to scrape. We have these books, and the books have prices. And if you click on the books, they have a project description, and they have availabilities and star ratings. Well, let's say sorry. Let's say I want to get only the prices and the titles and the descriptions. Okay, so I would go here. I go to the website, find out how to make a CSV file that gets titles, description, and the prices from the first 5 pages. So as you can see, I kind of already need to have an idea of what I wanted to do. Well, I don't actually need to have an idea, but it's good to have at least a bit of an idea. If I don't have an idea, I can also, in this first prompt, I can ask it questions, right? Like, I would like to scrape this, but I don't know how, you know, like, can you help me to find out? So that's all something we do in a plan mode. So what now Claude is doing is that it got the website, it got the detail page. Now it is building its own context. It's opened this website, it's looking at the project description, and it's going to, at the end of the plan mode, it's going to come up with a plan. That's kind of the purpose of the plan mode. Usually what it also does before it's done with the plan, it will ask me questions. It does that a lot. Also, sometimes the questions don't really make sense, but yeah. So I have everything I need. The structure is confirmed. Okay. And it said this is a very small task. But let's say I have my books now, right? And now Claude writes me a plan, and I would like to go further with this. I would like to connect it with a different data set, you know, then I would start a new plan mode. So look, so this is what I was saying about the prompt, that currently the agents write prompt for themselves. The plan is actually a prompt, right? So here it will tell itself what it needs to do. You know, I read the plan always, you know, because there can be things in the plan that are stupid, that you don't want, and there are things in the plan that you don't understand. Now, for all these three categories, there is an action, right? So for things that are stupid and you don't want, you want them to be removed from the plan. For things you don't understand, you can ask Claude about, or the agent about, okay, I don't understand what is beautiful soup. Explain to me what's beautiful soup. That, you know, so really read the plan carefully, and always, again, as I said, beauty of this technology is that you can ask it about yourself, so about itself. So, and sometimes I see something in the plan and I'd be like, hey, this doesn't look right. Is this really necessary? And then Claude says like, oh, they're of course it's not necessary. You're right. So just be vigilant and don't let the model do the thinking for you, right? You're still the one who's thinking. That's why when people come to me and I think this is fine, so I'm gonna say yes and do your thing. So now we exited the plan mode and we're going to the scraper part. When people tell me that, you know, that we are thinking less because of these models, I think that that's not true, because you still need to keep on thinking, and the fact that you don't understand something doesn't mean that the model knows it better than you or what to do. Sometimes it does, but sometimes it also doesn't, and this is not something you can just usually it's not something you can just bet on, like, oh, okay, probably does well. Okay.
Yeah, that now is the time also that you can learn quicker things. Like, for example, I've been a software developer for over 15 years, but I've learned most of what I know over the last year through using these things, just by having these things research everything for me.
So we did our plan, and again, the discussion, you know, that we did barely a discussion. The discussion could be longer. It is there to minimize random behavior, and this plan mode gives you this detailed plan. Now we are in the implementing phase. So this is what it's doing now, and it wrote the scraper and it's now running it. And then we review the output. So in case of scrapers, this is actually super nice for us, because to fact check a scraper output is super easy. You just look at the output and you look on the website, and if it matches, then you have the data. You know, it's really one of what I see in journalism currently, one of the most straightforward application of this technology is writing scrapers, because you don't have to rely on these like free tools that are super clunky and they get out of maintenance fast and they don't work, and or you don't need to like learn to spend three months to learn how to write Python. Paul?
I'll just ask a quick question because I know we have no time, but I didn't realize that. I didn't realize that you could simply check the output of a scraper that you built with source code just by verifying the content on one website. Because isn't there a risk that it hallucinated some of the output somewhere, or is that just fundamentally never going to happen? Because I've actually one of the areas where I haven't used LLM tools is for scraping, because of my fear that I don't have time to validate what it produced. Does that make sense?
Yeah, so the big difference is that what Claude does here is that it writes a script and it executes the script, which means that it's in its output, it comes from the script, not from Claude. So Claude is not, you get hallucinations when you rely on the training data. Yeah. So if you rely on the training data, you get hallucinations. That's why you shouldn't tell the model to do a data analysis for you. You should tell the model to write a script that makes the data analysis for you, because then you can review what the script does and then it doesn't hallucinate. Yeah.
Yeah, if it will hallucinate Python, the Python will simply not run. Or will simply not get any results.
Yeah. Oops. All right.
I would like to add one more little thing.
Yeah.
This plan mode that we just looked at is basically a way for you to write a prompt to start with in a new trajectory, a new conversation. So what is plan mode in all these tools, be it Codex, be it Claude Code, whatever, what plan mode often does is that you create this plan, and then when you say accept, this tool will clear the context before you created that plan, and will start with this plan as the first message. Ciao, Lilith. And there is something there that is also useful to know, and that is like when you talk with this thing, there is nobody on the other side of the line, right? It's just you and the statistical model, and you filling your context up and navigating this space of possibilities. So the more insecurity you put into this prompt, the more this model also becomes insecure, and the more this model also will not know what to do because it reflects your current state. So this is why plan mode is such a nice thing to use, because you can be very insecure in plan mode, and you can be like, hey, Claude, I don't know what to do. How do we do this? And Claude will research it all for you and will give you all the answers. And then boom, there you have this plan. It has all the answers. And then when you start with this plan, you start in a new conversation. And this new conversation is just, Claude, we are gonna build this thing. Boosh. And you want that because the more you have this like sort of like oh this, oh that, oh such and such in your prompt, the more of this sort of like insecurity there is, the more the output of this model will also follow that pattern, and the more you will get very derpy outputs. So again, keep your conversations short and keep them on point, and that is where plan mode really can help.
Yeah. Yeah, plan first, implement second, review always. And this was like iterate for bigger work. You want to write tests and use Git and stuff like that. Yeah, so now it wrote the scraper. I just probably have the books here in a CSV file. I trust it. Reviewed, check. Are there questions? Like we kind of rushed to the last part, but the last part is really just tying everything together. I find in this workflow, and the more complex your work is, the just you take this workflow and you repeat it multiple times, right? So if I want to build something and I don't know how to build it, I first just have a very long conversation with Claude. I do my own research. I collect some context. then I start a new conversation with that context, and then I'd be like, okay, I want to build this. Based on this context, how should I approach it? And then we make a plan. Then I clear the context again. I take the plan, implement the plan, see if it worked, you know? So it's really this iterative process where you always plan, implement, review, start anew. Oh?
This is just from your earlier slide, but is that media ownership visualization you did, is it publicly viewable? I'd love to look at it. It looks really cool.
I'll send you the login. Any other questions?
Yes, I have one question before it's too late. And basically, what, like, in the iterate phase of the reviewing part, what type of texts? Because it's okay that I can review and double check the materials from my Excel, but if it's really very big data sets, is there something scientific that I can follow?
Well, actually, it's a fantastic question because there is wait on. I have shared it also in the Discord. There recently came out a book, or it's coming out, about data. About testing data analysis, about writing tests for data analysis, which is, I find, super cool. And I can show, yeah, this is the test-driven data analysis, which has like loads of information. I'll share it here in the chat.
Lovely.
Which basically takes the theory from software testing and applies it to data analysis. And what I already really liked is that, like, for example, this beautiful diagram, like how usually you test your data analysis, right? It's like the it's pretty messy, and that it identifies a couple of errors that you can make in data science. So interpretation, implementation, errors of process. And this is, for example, a really nice thing to give into the context of Claude when it's writing text for your data analysis. What you can do is also just very bluntly copy paste all of this text, and of course read it before, and then give it to Claude and say, write me data-driven, write me tests for my data analysis that will test for these errors. Yeah.
Okay, thank you.
Based on this website, write me a plan to test my dataset and give also your dataset part of it, like the structure in context.
Okay.
Also, to leave you with something like how to use these agents best is also something that you can really ask your agent about, because your agent often has a documentation functionality where it can just look up the best practices that you can use for Claude Code or Codex, etc. Yeah, Esther.
Yeah, so I was wondering, so skills, if I get it right, are these kind of contexts that you use repeatedly, right?
Yeah.
So have you been writing skills? Have you been like sharing skills? Like there's also skills for journalists out there. Like are there good ones? Is there not so good ones? Can you say a little bit more?
I write my own skills. I, for example, for the Pond, I have a newsletter, and I have a skill for Claude that what it does is that it uses the Chrome web tools, which means that it opens websites, to go to Discord, open this reading tips channel, get me like the last couple of links, open this datasets channel, get me last couple of links, go to the events, get me all the events that are planned in the Discord, goes to the previous versions of the newsletter, finds me all the links that I already shared, and then basically writes me a draft of a newsletter. So that kind of makes it easier for me to make a newsletter. I have seen many like these get like these 87 tool, the 87 skills for journalism. I am very skeptical. I also saw somebody sharing it here, like this guy who makes like very many of them. This guy here, and I mean it looks really cool, you know. But I like when you look in under hood, it's just a couple of skills, and I would really just want to read the skills and see how I can adapt it myself, and if it's really useful for what I'm doing, and not just blindly trust on this. I don't know. I'm very skeptical.
It's prompting.
Okay.
You don't know what you're.
Mute me, Ada, so that I can have my mic. The problem with prompting is that if you don't know what is in your prompt, then how do you interpret the results that you get from this model? So these skills, they are little pieces of context that get loaded into your context window on how to approach a certain journalistic investigative strategy or approach. Well, if you do not know what is in these skills, what is that going to be worth to you other than just relying on some nonsense that the model itself has? So you're basically trusting this person that wrote this skill fully with what you think the model should do. So if you're talking about skills, I would say it's worth a lot if you notice that you are doing the same thing with your coding agent over and over again. Or with your chat, you know, then making a skill out of that is extremely simple, because you can just seriously ask the model, hey, make a skill out of this. Boom. So it's really for the stuff that you yourself want to make. It's really useful. This whole sharing of skills, I'm not so sure if it's that useful.
You can like read through it and you can take the parts that you think are useful.
Yeah.
But I also don't think like this is like it's necessarily always comprehensive. It doesn't necessarily always like fulfill your needs. I think that the beauty of agents is that it's very much yours, and you can make it very much yours. You don't have to rely on the flavor of other people or what other people need. Yeah.
Because I was also kind of thinking it, or the idea popped into my head when you showed the book, right? Like, so the book is a testing book, and then like you can put that in your context. But then I'm also thinking, well, like if somebody that I trust, or for example you, right, I have like put this into a skill, then I might need explanation on what it does, but I would then trust, I guess, that I don't have to just feed it into a skill myself.
I wouldn't trust. I think that's kind of the thing, because also we're working with local agents, which means that they can do stuff on your computer. It means that they will execute code. They will read your files. Although it's true that the one that Rui made a skill, and I just use it a lot, and I never really read it. So I'm also just full of it. But here there I really trust that he knows what he's doing. Well, this guy I don't know. I never heard of this guy. So yeah.
And then maybe a general question, like, is there any other safety kind of tips that you have that we should always take into account? Like things like starting in a separate folder. Like if you start in a folder from scratch, will you have to tell it that it cannot browse or go outside that folder, or will it automatically not do that, right? Like, is there things that we really need to watch out for?
Well, it will ask your permission for it to go outside of that folder. But you have to understand that you give a model, you give it access to execute code on your computer.
Yeah.
So this is all theater, I would say. It is all putting up small little walls around the model, but it's all very low walls, if you know what I mean. Like there is always inherent risks with giving these models access to your computer, especially if they can execute code. Like yeah. So there is, if you really want to be safe, there is ways to contain applications on your computer, but then you get into like containers and virtual machines and that kind of stuff.
Yeah.
Which can be also nice, by the way, because Claude Code asks your permission a lot, right? Can I execute this? Can I write a file? Can I do this, etc., etc.? And you just there pressing yes. I know you are. I know you don't read it all. And if you put Claude into like this little container, you can just tell it that it's all okay. Whatever you want to do, Claude, you just do it. You go wild. And that is actually a way to be way more productive with this kind of stuff, because you never have to press yes. Gabriella?
Sorry, John, what's the name that you said is of these containers? Like, what's the right name to refer to a container?
Yeah, you can have like Docker Claude Code container. If you ask, well, a container, the right way to refer to a container is it's called container. But there is also for Claude Code, I don't know what you use, but for Claude Code there is this specific thing called development container. And if you use something else, you can. I just shared the link. Like if you use something else, you can ask the robot how to do it. Depending on your platform, it's a bit different.
Okay, thank you.
You're off mic.
Sorry, is that when we were at the conference, like, and we were having this hands-on part, is that we got lots of questions on, okay, how do you do this in Codex? How do you do this in Claude Code? But the answer is always ask the model. They will tell you better. I don't know. I've never worked with these tools, but the model will be able to talk about its own usage, and if it doesn't know, it's able to pull in context to be able to talk about it. So if you, for example, want to do a development container with Claude, ask it and work with it, plan, implement, and review. All right, guys. Well, thank you so much. I really liked all your questions. Thank you for being here with us. You know where to find us, I guess. Next week, we'll have a session with the one and only Jonathan Stoneman about maps. So if you're curious, please come visit us. And yeah, if you have any questions, hit us on Discord. We're always happy to help. All right.
Thank you. Bye-bye.
Fun. Have fun. Bye.